Hello everyone, nice to meet you. Let me introduce about myself. My name is Sujatmiko. I'm an informatic engineering student at Dian Nuswantoro University. I also as an author alongside with my partner. On this video, I ask a speaker to present about our research paper with the title of AlexNet Architecture-Based Convolutional Neural Network for Real-Time Audio to Text Translator of Bisindo hand sign. Let's we move to next page. The first thing that we will talking is the information. If we know the information, we will understand what is talking about on this video. The first thing is information about deepness, then purpose, third is purpose, and fourth is the reason. The first thing is about the deepness. Deepness is a condition when the people is lost their hearing function. Like I, you, and we can understand about this information by the oral language that was received with our hearing system. But how with them? Who is unable to receive the information through the hearing system. So they will need another substitution or any solution. The best solution is by using the hand sign language. On this my country, at Indonesia, there is two kind of hand sign. The first thing is CB and the second is Bisindo. Both of them serve the same function. First thing is CB, often used for formal thing that was created by our government. But second is Bisindo. It's much more convenient and fluid to use by the student and the community in our country. It was developed by them, so it's much more convenient to use and can provide any combination of hand that was provide the language that we can use daily and much more simple. And the second is the purpose. What is the purpose of this research? The purpose is to find out the algorithm for image processing that are effective to be implemented in Bisindo sign language translation system. So we will find out what the best algorithm that was we use on this research. Third is the purpose. What is the purpose of our research? The purpose is the study we use the CNN AlexNet algorithm architecture to detect Bisindo sign language and translate it into the output of text and audio. The last one is the reason. The reason is to provide much more information about the effectiveness of AlexNet CNN algorithm in the implementation of Bisindo sign language to detect in real time. As we know about the information, we can now move in the next page. Alright, in here we will talking about CNN and its own architecture. There's many variety of the architecture as you can see on the right side of the table. CNN provide like it's an artificial neural network that replicates the mechanism of human visual cortex to distinguish and classify visual objects that can be recognized by the computer. So the CNN is to replicate like the system on our brain. Our brain is very special. It can distinguish the classify visual object, like we can understand and determine what object we see and we know if that is correct or correct. So the CNN try to replicate it, and then CNN has variety of the architecture. One of thing that we use in here is the AlexNet. AlexNet have such many of characteristic in here, like the depth is on 8, the size is not too big, only 2 to 7 megabyte, with parameter is 16.1 million. The input image is not really small or not really big. Next, the feature extraction. As we know, the image we usually see is the image that we see usually on the color image. The color image in the digital image is in RGB or red, green, and blue. Here on your left side of your screen, there's original image. It's the sample of a hand sign that we took as dataset with 27 by 27 of megapixel. First thing, this image was picking up on this a bounding box. We focusing on which we will detecting and then convert it into a matrix. The matrix is the number between 0 until 2 to 5. If 0 is mean darker, or we will not using it. If the value is much more or above the 0, usually it's giving us a visual. Then when we is converting into matrix, we will separate it into 3 layers: red, green, and blue. Third of that have its own value. Red, green, and blue have different value on the matrix. When it combined, it will make something that be recognizable as an image. Other that, on the right side is convolutional layer. Convolutional layer is to make its processing. The original image can be recognized by our system. In here is the image with the size of 2 to 7 by 2 to 7 multiple 3 layer will be converted to much more small pixel with 11 by 11 megapixel with the stride is 4. Stride meaning when there's many grid of the matrix or the image, it will be skipping for time of each detection, and then it will be converted to much more smaller size with much more smaller stride too. And then we connected of this pixel into fully connected layer FC, and then going to FC, we will get softmax with the value of 1000 of the result. Parameter in here is about 16 million parameter. It's very great number, but we will see later how good it is. And then in here the mathematics of how converting the image into the matrix. As you can see, it's the process of feature extraction. We will go on the next step. Data augmentation. As we know, we will need a data or data set to make this project happening. The data set in here is from a letter of Bisindo sign alphabet from A to G. All of this image is taken with various of person. In here is my cousin. Each of us is taking 115 images of each letter in here. So I and he is switching the place. One letter will took about 300 images. In here we have 26 letters. So the image that we need is 7800 images stored in JPEG format. The participant is two, me and my cousin. The instrument that we use is DSLR and ring light. The DSLR is have great pixel and can picking up the deep and the focus on the hand in here as our main focus of detection. The ring light is helping us to visualize and bring much more bright, so the camera is optimal to taking the picture. The first thing in here is the original image. The original image we took with the DSLR is stored with the size of 3008 and 2000. It's way much more bigger than the AlexNet can provide for detection. So we bring it down into 2 to 7 by 2 to 7 megapixel. We resize it down so it can be accepted with our system. In here a proposed scheme. Let's break down the diagram. The first thing, the step that we must do is the training. Training is contain the dataset 7800 images in JPEG format. Dataset in here that we was collecting before. After we collecting and store with labeling each of the images from A to Z, so we get 26 labeling. After labeling, we can feature extraction by convert image into matrix. When we get this extraction, so we can make the model or template to matching the detection. So it's became the recognition system for matching input from training dataset. Here is the training dataset and here is the real time. The first thing that we do is by start the program. When the program starts, it's connecting the camera with the system. It could be webcam or unsupported camera. You can hooking up camera like webcam, DSLR or any other that supporting the system. So the process is like you align your hand in the front of the camera. So there's a pointing box around your palm. Like if I'm doing it, it's mean A. So camera took the snapshot of the hand. It's very quick, under 1 second. It's about 1 millisecond or less, so it will be much more faster. And then we will transmit back the image that we was captured. So matching with the template in the recognition system. If we matching, we will get the output of two output. The first one is the alphabet letter that appear on the screen, and then the second is the audio that we can hear from the speaker. In here, there's two steps, training and run the program. The first thing is training, and the second we can use this program. If all of this is work properly, we will get a good result in here. Alright, let's move on. Testing. In here, in the table, we testing the algorithm of the AlexNet. There's like the epoch, iteration, time elapsed in hours, minute, and the second. The mini-batch accuracy and mini-batch loss. At the end, we get the best learning rate. The table involves setting 20 hyperparameters step to achieve the optimum level and avoiding overfitting or underfitting condition in the feather extracts, which would result in a flexible program behavior during object recognition. Each step required an estimated 6 minutes. At the beginning of the process, there was a pike in the mini batch loss. Batch loss of 3.1556 points as the step progressed, and the loss decreased by 75.96% and continued to decline until it reached the minimum value of 13.75%. So when it's reached much more epoch or it's bring until 20, I'm sorry, cannot show you in here because covered by the camera. So it will be decreased, and fast learning rate remain is consistent from beginning to end with value of 0.0010. Indicating a constant scale. The testing that we conduct was using black box testing with 122 experiments. It's very much, which yield 468 correct detection with 52 error when averaged across 26 letters. This result in a 2% of MS error or mean square error that we get. How are we counting it? By iteration as total dataset per batch size. So based on the calculation, 316 values were obtained in one epoch. Training table consists of 14 epoch steps. Therefore, when calculating this result in 14 multiple 360, we get the result of 5,320 iterations. Each of 26 characters available in the dataset was tested 20 times. The result is a total of 522 characters on average. So, the accuracy is determined by true detection result per number of total testing multiplied by 100. So, accumulation of 522 experiments that we conduct, which yield 468 correct detection when averaged across the 27 letters. This result in 2% of MSA. Alright, in here we will talking about the scenario, testing target, and the result. The first thing is the scenario. When we use the pair hand, the system able to detect hand movement accurate. So the answer is yes, it's accurate. How if you use glove? The system able to detect the hand movement wearing glove? No. It said no, it's unable. In indoor, it said yes. Like in the city, the system able to detect hand movement accurately with bright ambient condition. It will always say yes. research limitation. As we know, this research is going from the stretch and is not yet perfected well. The letter that share similar symbol patterns such as I, L, R, U, and V and Y exhibit a higher MSA of 50% is due to a one-for-one comparison of misidentification from image that have the same pattern. Look at here. When hand side E or L, if I'm moving hand or a little bit, the camera cannot detect my thumb, so it will set E. If we align what the surrounding can cause it into E. So the pattern in here is as an error or limitation. When I set R, it can be U because in here it's not much two differences. The result and the future research. CNN, AlexNet architecture apparently reliable with 19% successful rate. Development of a real-time language translator system based on a CNN algorithm with AlexNet architecture was successfully implemented and is possible, giving us a good result. The system achieved a hack detection accuracy of 90%. The system effectively classifies hand signs with minimal errors based on labeling process. Also, add future detection into complete sentence with Indonesian dictionary rule. I think it's enough, guys. Here is the reference that we use. Thank you. Any question or responses? I will be glad to answer all of you. Thank you so much.